All right, the next lesson in geometry is called triangle congruence proofs. So we are going to be doing proofs again like we did in Unit 2. Example 1, given that AC is congruent to DC and AB is congruent to DB, prove that triangle ABC is congruent to triangle DBC. So we put both pieces of given information in statement 1. You can split them up if you want, then you're going to use 4 steps. So you have to add on another step. And reason 1 is because that was given to you. Now, if the diagram is not labeled, you should go and label that yourself, but this one's already labeled. Okay, so I have to prove that this triangle, ABC, is congruent to this triangle, DBC, and there's 5 possibilities. Think back to the last few lessons and the quiz we just had. We could have side, 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 angle, 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 side, or hypotenuse, leg. Okay, so let's see what else can we get from this diagram. We know that BC is congruent to itself. So I'm going to say that BC is congruent to BC. Do you remember what that's called? It is the reflexive property of congruence, reflexive POC for short. And now that I have that, I can say that triangle ABC is congruent to triangle DBC because of side, side, side. Side, 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 side. Number 2, given that XZ is congruent to VZ, and that's already labeled for you, good. And YZ is congruent to WZ, and that's also already labeled for you. If it's not labeled, just make sure you label it yourself. That reason is given. So now you have to ask yourself, what other piece of information can you get from the diagram? You should know that this angle and this angle are congruent because those are vertical angles. Now, when you name those angles, you're going to have to make sure you use 3 letters and make sure Z is in the middle because that's the vertex. So I will say angle XZY is congruent to angle VZW. That is the vertical angle theorem. All vertical angles are congruent. And now we can get to what we had to prove. Now we can say that triangle XYZ is congruent to triangle VWZ. What is that reason? Side, angle, side, side, angle, side. So SAS, side, angle, side. Again, the reason why it's side, angle, side is because that is the included angle. Okay? Example 3. Given that AC is congruent to DB, and that's already labeled for you, so that's good. And you're given that angle ABC and angle DCB are right angles. So that'll be my given information. I'll put that in statement 1. Now, whenever you do these hypotenuse leg proofs, you need to include the step where you say that you have right angles, and you have to include a step that you say you have right triangles. Those must be included in these proofs. You have to say that you have right angles, and you have to say that you have right triangles. So that's why statement 2 is in there. Next, I'm going to use the reflexive property of congruence, and I'm going to say that BC is congruent to BC, and I label that in my diagram. And now let's see, now we can say that the two triangles are congruent. Above it said you had to prove that triangle ABC is congruent to triangle DCB, and I'm going to claim that we already have proved that, because if you look above, we have the right angles and therefore the right triangles. We have this hypotenuse congruent to that hypotenuse, and we have this leg congruent to itself. So my last reason will be HL, hypotenuse leg. Okay. On to the next example. Given that AB is congruent to AC. Now that's not labeled for you, so you should label that yourself. And you're given that AD is perpendicular to BC. Now, since they're perpendicular, it means that angle ADB and angle ADC are right angles. That is the definition of perpendicular. Let me label that. These are right angles, each one. Then you have to say that triangle ABD and triangle ACD are right triangles. You must include that in these proofs for HL. And again, next we're going to use the reflexive property of congruence. I'm going to say that AD is congruent to AD, and I label that just there with 2 tick marks. AD is congruent to AD. That's the reflexive property of congruence. And we can now prove what it said above. We can prove that triangle ABD is congruent to triangle ACD. Why can we prove that? Well, we have the right angles and therefore the right triangles. We have this hypotenuse congruent to that hypotenuse, and this leg congruent to itself. So hypotenuse leg. Okay, so that's the first half of this lesson. The first half of this lesson was proving triangles congruence. And now the second half involves one extra thing. It comes from this acronym right here, Cpctc. Cpctc is an acronym that we use in geometry. It stands for the following: corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Cpctc is a justification that can be used in the proof once you have proven that 2 triangles are congruent. So keep the following in mind: side, 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 angle, 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 side, and hypotenuse leg. Those are used to prove that 2 triangles are congruent. Cpctc is what you use after you prove the triangles are congruent, and you use Cpctc to show that 2 angles are congruent or 2 sides are congruent. Think back to the very first example we did in this unit, where I gave you a problem like triangle ABC is congruent to triangle DEF, and I said write the 6 parts that are congruent. That's what Cpctc is. Okay, so example 5. Given that YW bisects XZ, and we're given that xy is congruent to zy. So xy is congruent to zy. Let's label that on the diagram. It says that xz is bisected, so xz is cut in half. So that's why the next statement says xy is congruent to xw is congruent to zw. Definition of segment bisector. Okay. Now, example 5 is just like examples 1, 2, 3, and 4, except there's one extra step at the end. The very last step is Cpctc. Whenever you have to prove two angles are congruent, or if you have to prove two segments congruent, that means your last reason is going to be Cpctc. But in order to use Cpctc, we have to first prove that the two triangles are congruent. So right now, I'm trying to prove that the two triangles are congruent. And I'm going to use the reflexive property of congruence next to say that wy is congruent to wy. Reflexive property of congruence. And now I can say that the two triangles are congruent, but be very careful when you write the order. So I'll say yxw is congruent to triangle yzw. We've talked about that a lot already in this class. Making sure you go in the same order when you name a triangle. And that reason is side, 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 side. And now, since I know the triangles are congruent, I can say that all the corresponding parts are congruent. So I can say the angle XYW, that angle up there with the star, is congruent to this other angle with the star. And we're using 3 letters, so I know which one you're talking about if you look at the diagram. And that is Cpctc. Corresponding parts of congruent triangles are congruent. Okay? One more example. PR bisects QPS and PR bisects angle QRS. So that'll be my first reason given. My first statements are going to be the things I just read. PR bisects angle QPS and PR bisects angle QRS. Given. Then it says use the definition of an angle bisector for statements 2 and 3. So if angle QPS is bisected, then it means angle QPS is cut in half into 2 congruent angles. So this top angle is going to be congruent to this bottom angle. So I'll name that with 3 letters. I'll say angle QPR is congruent to angle SPR. Then I'm going to do the same thing with the other angle that's bisected. Angle QRS is also bisected, so it means angle QRS is cut in half. So the top angle is going to be congruent to the bottom angle. So I'll name that with 3 letters too to avoid confusion. And I'll say angle QRP is congruent to angle SRP. Now remember, I'm trying to prove that the 2 triangles are congruent, and then I can say if the corresponding parts are congruent. So right now I'm trying to prove that the 2 triangles are congruent, and I can use the reflexive property to say that PR is congruent to PR. And now I can say that the 2 triangles are congruent because I have angle, side, angle. angle, side, angle. So I'll say triangle PQR is congruent to triangle PSR, angle, side, angle. Be very careful when you write your triangle congruence statement. So P from the top one corresponding to P from the bottom one because they each have one arc. Q from the top triangle corresponded to S from the bottom triangle because they each have 0 arcs. And R from the top triangle corresponded to R from the bottom triangle because they each had 2 arcs. And now I can prove what I had to prove. Prove PQ is congruent to PS. I can prove that because corresponding parts of congruent triangles are congruent. So that's a difficult lesson. Those were our triangle congruence proofs.